So we're talking about similar triangles today, and have you ever seen this before? Anything like this? Done anything with similar triangles? Have you? Yeah? Okay, I thought maybe you've seen something along these lines before. We have two triangles here. What do we, ABC and LMN, right? And what do we notice about these two triangles? So we notice that, thank you, that it has these two angles marked with the same symbol, and these two marked with the same symbol, okay? And what do you think that tells us? Anybody have a guess? You would have seen some of this in grade 9, not maybe in triangles as much, but that they have the same angle, right? That their angle measurement is the same. So M is the same as A. How would we write that? We would write angle M is equal to angle A. And then we could say angle L equals angle B. And what about C? You got to tap into what you know about triangles. You're going to need to know a lot of this stuff for this whole unit. So think back to grade 9, what you learned about triangles. How do you know? Without reading that, how do we know? Very good. But without reading that, how do we know? What do you know about the three angles in a triangle? They always add to 180. Every triangle, that's a proper triangle with three sides that are closed shape, not some weird triangle that somebody made up. Call it a triangle, right? Every real triangle, the three angles always add up to 180 degrees. So if it's got two of the same angles, the third one has to be the same as well. Doesn't that make sense? 180 minus this. It doesn't matter how big the triangle is. That's the whole point. The three angles still add up to 180. So if two are the same, all three are the same. So we can deduce from this that angle N is equal to angle C. And so look at how we write this. Triangle ABC. See this symbol here? It means is similar, not equal. If you say equal, that's 100% wrong. This is a notation thing, but they're not equal. The triangles are not equal, but they are similar. The angles are equal. The measure of the angles are equal, but the triangles themselves are similar. And what does that mean? It means they have all three angles equal, and it means something else that we're going to get to in a minute. So we use that symbol to communicate that in mathematics. It means similar to. So triangle ABC is similar to MLN. Notice how ABC is alphabetical, but MLN isn't, because we are kind of picking. Now, we're not doing a lot of similar triangles, so we're not really going to get into this. But A, if you look at these, A goes with M, B goes with L, and C goes with N. So I wrote them in the same order that the angles go with. So that would be a typical convention that we would use to show which angles are similar. If you're making, we call this a similarity statement. And if you're saying that two triangles are similar, you should line up the angles appropriately. Does that make sense? It's an easy idea, easy thing to do. Like, this is not hard compared to a lot of the stuff that we've done in this course. But you got to remember to do it. It's a bit picky. Why is this useful? This is useful because when we have two triangles that are similar, their side lengths are proportional to each other. What does that mean? It means, let's say side length MN is twice the length of AC. That means every side length in that bigger triangle will be twice the length of the side length in the other one. That's what it means. If one is twice, they're all twice. If one is 3 times, they're all 3 times. If one is half as big or 50% bigger or something, the other one has to be this. Every other side is the same. Okay? And you're not adding. It's not like if you add 5, you add 5 to them all. No, it's proportional. So we're always talking multiplying here. Whatever the multiplier is, it's true for all of them. Does that make sense? And again, this is easy. Like the mathematics, the computation is really easy. So it's just setting it up, and it's just understanding these things about similar triangles. So let's try a couple of these. Use similar triangles to find each missing side, round to one decimal place if necessary. So if you like, you can start by, we have to look at the angles, and if you like, you can write this out, but I imagine with a little bit of practice, you probably won't want to. It's probably a little bit too easy. But let's try this. So over here I have angle A is equal to which? Christopher? Nice. Angle B is equal to, Ahmed, which one? Angle J. And that means angle C is equal to angle L. And then what I do want you to do every time is triangle ABC C is similar to KJL. And I want you to get that in the right order. It's not JKL. It's not just always alphabetical. Think about the ones that go together. Does that make sense? And I should have triangle in there. Everybody okay with that? You understand what I did? We matched up the equal angles and then wrote our similarity statement. And now, here's what we can do with our similarity statement. I start with AB over KJ. So I took the first two here and the first two here, and I wrote them as a proportion. Is equal to BC over JL, which is equal to CA over LK. The order doesn't matter, but if I start with the first two, I have to do the first two, second two, first and third. But like A, B, B, A, that part doesn't matter, but try to do it in, like, if you do it systematically, then you'll probably be fine. Got that? Any questions? Everybody still okay? So what does that mean? Well, AB, we're given a side length, so it's 5 over KJ, which is 13. I'm just picking these out of the picture. Still okay? BC is blank, so it's just BC for now. JL is blank, so it's just JL for now. And CA is 8. And LK or KL is X. So how do we find side length X? This is the whole point. Is if we know that two triangles are similar, I can have measurements in one to find measurements in the other. That's the whole point. And this is actually a very powerful idea, I'll tell you. There's like huge amounts of mathematics built off this simple idea. All of trigonometry is basically built off of this. Surveyors, like geographical surveyors who are, making maps, or cartographers are making maps, or like surveying canyons, would use this kind of math to survey and measure distances like constantly. We have tools these days that do it kind of electronically, but it's all still built on the same process. So what were you going to say? Are you sure? So just watch for a minute. In this case, because this one has no measurements, and I'm not asked for anything in it, I don't know anything in it, I'll just cross it out, like I'm not using it. And so I end up with 5 over 13 equals 8 over X. Okay, and I'm just solving for X. There's lots of ways you can do this. I'm going to do it a particular way, but as long as you're like showing your steps and stuff properly, then if you have a different way of doing it, it's probably fine. So I'm going to, whenever X is on the bottom, I'm just going to flip both. Okay, so now I have 13 over 5 equals X over 8. And this is just like a mini equation, so I'm just going to multiply both sides by 8. And on my calculator, I do 8 times 13 divided by 5 equals, and so X equals 20.8. That's it. Like, we're done. Like, what do you mean? 8 times X goes like this, right? They're gone. So that's why I'm left with just X. Like, I flipped sides here, right? Like, this side would be 20.8 equals x. But once you've done a bunch of these, it's this, like proportions, this is a proportion. Again, powerful math, but very simple. But once you've done it a few times, they're all the same. Okay, so almost nothing we do with similar triangles is harder than that. That's about as hard as it gets. Okay, any other questions? Okay, I want you to try this one on your own. Do it exact same way. So triangle something is similar to triangle something. Yep. They're supposed, yeah, 50 kilometers. Yes, it is supposed to say that. So units wouldn't matter, right? Like I can't have kilometers and centimeters in the same triangle. I would have to convert then. But kilometers in one triangle and centimeters in the other, that's okay. That won't matter. That won't change anything. Cross multiply is not a thing. It's something that's made up. Yeah, no, but it's not a thing. Like it's not like cross multiplication is not an operation that we can do. And cross multiplication, whenever I hear that, it destroys my soul a little bit more every time. So Ahmed, thank you for that. But the reason is because when students love cross multiply because it seems to make it easy. Like you say, it worked, right? What you did worked. But then they start thinking that it's an operation that they can use in all sorts of other places where they can't. So I don't cross multiply and I don't talk about cross multiplying. But like I said, whatever you do works. The only thing with, I would imagine when you cross multiplied, you ended up with like 5x, and then you had to divide by 5 on the other side. I just left the 5 on the same side and divided by it anyway. So cross multiplying is a little bit of extra work, in some cases at least. But anyway, so as long as you're showing your work properly, I'm sure it's fine. But Ahmed and everybody, I would be careful. Cross multiplying is not a thing. What you're doing is solving an equation that's got a few fractions in it, and we have methods for that. We just have to make sure we're using things we can. Okay, so who can tell me what the second triangle here should be? So ABC goes with what? Like, what's the right order? LMK. Is that what you said? So LMK. So A goes with L. B goes with M. That's a right angle. And K is the empty one, so exactly. Very good. Okay, and then we just set up our, now we're solving for 2 angles, so go ahead and try to set that up. Okay, so I can start like AB over LM equals BC over MK. Okay, keep going, and then fill in those blanks. Looks like there's a measurement missing. I was formatting this and it probably got deleted somehow. So there should be a 6 centimeters on the top there, but hopefully you've got something like this. Again, like we know stuff about right triangles. So I've got a hypotenuse. X is the hypotenuse of one triangle. 10 is the hypotenuse of the other. Notice how they go together, right? And then the 2 smaller legs, 50 and 6, go together. And the 2 longer legs, they look longer in the picture. 8 and y go together, right? That's what we're talking about, proportion. You can't change that. If you got them in the wrong order, if you had y over 10 and 50 over 8 or something, then you'd be getting the answer wrong, right? Okay, so now I'm going to break this up into 2 separate questions. Y over 8 equals 50 over 6, and 50 over 6 equals x over 10. And Ahmed, this is what I was kind of talking about. Like, if you cross multiply, you bring the 6 over, and then you just divide by 6 in the next step. So why bother? I would just go times 8 times 8, and in one step, y equals 50 times 8 divided by 6, which is 66.7 approximately. Okay, try the next one quickly on your own. Easy stuff. What do you multiply by, then how do you get the answer? I like to think of these as equations, not like once I get the proportion set up, it's the equation that I'm solving. So I multiply by 10 to move it to the other side. This gives me 83.3. Yep. Multiply by what? No, you multiply by whichever one is under the x. Right? I'm solving an equation. I'm just trying to move everything away from the x. It's just these equations, like they are no different than all the other equations that we solve, but they happen to look like each other because of proportions. But I'm just multiplying by whatever's with the x. In this case, you're right, it happened to be the bigger number, but it's not always for sure. Any other questions? Everybody good? All right, let's see. On the other side. Somebody tell me something about this question. There are two sides that are parallel. Very nice. And how does that help us? What does that do for us? This is grade 9 stuff. Which are what? Yeah, what are the letters that go with those? Do you know? So don't worry about the names of them, alternate angles and corresponding angles. Don't worry about that. FZC, that's all we care about, okay? So when I have triangles, that are touching, there's two things that I can do. I can notice that this angle is the same as this angle. What's that theorem called? Opposite angle theorem. Right? Again, don't worry, you don't have to worry about the name, but we know that those angles are equal. So we've got one pair of equal angles. If we can find one more, then we've got all equal angles. And so, oops, I'll use my little highlighter trick here. And watch this. So I go like that, like that, like that, and I found a Z, right? And with my Z, I can show, I'm going to use like a dot here for here. Those two are equal. And then similarly, I could use, whoops, I was going to use a different color. 2 lines to show that the other one, Z pattern. So in each triangle, I have 3 pairs of angles that are equal. So I have similar triangles. And we're not even going to bother answering this one because it's the same thing. So I think we're good. You can try it if you want after and make sure that you can get the right answer. But everybody good with that? Now these are called, so B, example B here, they're called nested triangles. One triangle is inside the other. We still have to use sides of the triangle. People want to use 34 and y, but y is not a side of the triangle, so that won't work. So let's set this up and see what happens. So one of my triangles is ABC, and the other one is ADE. They share an angle. So angle A equals angle A, right? Angle B and angle C. And B goes with which one? It goes with D. And C goes with which one? It goes with E. And actually, it doesn't tell us, but how do we know that? Anybody? We could use a C, but you'd have to do a kind of a little bit of work or like logic to do that. There's an even easier way. If I look at them as an F, and F tells us that this is equal to that. The C rule tells us 2 angles add to 180. A little bit trickier. Okay, F rule gives us those 2. So I know angle B is equal to angle D. All right, so that means triangle ADE BC is similar to triangle ADE. So again, I'm going to do this I'm going to do it the long way. So AB over AD equals BC over DE. You don't have to write out all three every time if you know which two you're going to use. Like we're only going to use, well, actually, if we're doing X and Y, we will use each of them. And then AC over AE or CA over EA, it doesn't make a difference. So AB, what is the length of AB? This is the hard one. This is why we're doing this example. No. If it's an isosceles triangle, but we don't know that it is. 34 plus y, thank you. And what is AD? 34. What is BC? 55. What's DEX? AC is 65 and AE is 35. So I can set up two equations. Now I can kind of forget about the triangles, and I get y plus 34 over 34 equals 65 over 35. You have to use the proportion that's got two numbers in it, right? You can't have y and x in the same little equation. Okay, and then in fact, when I write this one down, I can just flip it. X over 55, but you got to flip both sides, equals 35 over 65. What?
Would it be 55 over x for the first equation? Or 65 over 35?
So for the first one, I used that and that, right? Because you got to use one with that's got two numbers.
Oh, okay.
I can't have y and x in the same thing. And for the second one, I used these two, but I flipped them. So I flipped them both. So x and 35 were on the bottom. Now they're both on top. If that's too fast for you, no, I'm not saying that, but like do it in 2 steps, all right? Don't force yourself. You can easily do that in 2 steps. So if you were to cross multiply this one on the left, it would take a bit more work because you'd have to like use the distributive property and stuff like that. So what I'm going to do is just multiply both sides by 34, which gets rid of this, right? And I get y plus 34 equals 65 times 34 over 35. And then I'm going to subtract 30. You can do this in 2 steps, or like you don't have to write it out exactly the way I do either. I'm going to subtract 34 from both sides. And so this one's just going to be like minus 34 at the end, right? And I can, again, do this all in 1 step in my calculator. I don't want to round. Divided by 35 minus 34. Because it does give me a decimal. And you should be able to get it exactly 29.1. How's that feel? A little bit trickier. You don't see those too often, but they happen once in a while. Where you get a y plus 34 over 34 or something like that. Okay, let's see. This one we're going to skip. It's basically the same, and that one looks to me a lot like the same. Why don't you try this one on your... Actually, wait. Now here's what we're going to do. We're going to do our word problem, and then I'll let you try those couple, and then we'll be done. Now, applications in this course are tricky. Do you agree with that? When we did linear systems in particular, and then these quadratics that we've been doing in the last unit, in Unit 6, they are hard. Let x represent, let y represent. You got to set it up. You got to do all this stuff. It's tricky stuff. Word problems in this unit are not like that at all. They are quite easy. They're not setting up. They're not developing equations. The only trick is you want to draw it and label your drawing properly And once you've done that, they're very easy word problems. So it's nothing like the last one. This unit that we're doing is much more straightforward. A lot of people, it's their best mark of the course, but that doesn't mean you get to slack off. It's very new. Just what it means is if you practice, you'll get good at it and you'll be able to be very successful. Okay, but especially when we start trig tomorrow, you'll notice this. Okay, so let's take a look. On a particularly sunny day, you measure the shadow of a tall tree to be 19 meters. At the same time, you measure your own shadow to be 1.2 meters. Then it gives you your height. How tall is the tree? Let's see if I can. I can't. Too bad. Okay. So I'm just going to have to try to draw some nice right triangles here. There's one, and here's the other. So all these shadow questions are based off the premise that the sun casts a shadow at the same angle if it's happening at the same time. So I know that this angle and this angle are the same. And these are both right angles because it's the height of something. And now I can throw in my labels, and then it's just a similar triangle question, really easy. See how easy that is? So if this is like me, and this is the tree, right? So where does my height go? I know I am 1.7 meters tall, and my shadow is 1.2 meters long. And the tree has a shadow of 19 meters. And then I don't have to say let x represent the height of the tree, but I have to put x into the diagram. Is that good with everybody? And in this case, you can label these A, B, C, D, E, F and do the whole thing. But usually with these, it's really easy to tell which goes with which. The height of the tree is going to go with my height. And then the tree is on top, so the length of the shadow of the tree goes with my length of the shadow. And you do have to see that height is on top for both. Wait, no, sorry. The tree is on top for both, and me is on the bottom for both. Do you understand what I'm saying? Like, you can't flip it. X over 1.7 equals 1.2 over 19. Right? That would give me the wrong answer. Okay, why don't you go ahead and try to find that answer? Who's got an answer? Yeah. 30.8, that's not what I got. 26.9. Check and see why that was wrong, because that's weird, because it's really easy. Just make sure you didn't hit a divide or minus or plus or something by accident. 26.9, and that's meters. And this is a application, right? So we want to summarize that. That's not an answer to our question. Therefore, the tree is 26.9 meters tall. So I know that the height of trees is not all that interesting, but you can see the power of this. With a couple of easy measurements, you know your height. And if you have like a tape measure or something, it's really easy to measure a couple of shadows, and you can find the height of really tall buildings or trees or something like that very, very easily with very simple math. This is the power of similar triangles. Any questions? All right, that's about it. So here's what I want you to do. I want you to try this one, and then there's going to be some practice. I'll put it in the classroom, and that's that.